Now we are looking at 6.2. So in 6.2, we want to find the composition of G and F and the domain of the composition of G and X. So we know that this over here, the composition, can be written as G of F of X. And in this case, our inner function is F of X and our outside function is G of X. So this means that where we see X here, in G of X, we're going to put F of X. So then this will be equals to G of X plus 1 over, sorry, it will be equals to F of X. Remember, we say where we see X in G of X, we'll actually write F of X. So this will be F of X plus 1 and F of X plus 2, right? Now, this will be equals to, what is F of X? F of X is X plus 1 over X plus 1 over F of X, which is X plus 1 over X plus 2. Now, to simplify this, let's start with the numerator. So in the numerator, we write everything in the numerator as a fraction. So this X can be written as X over 1 so that it looks like a fraction. And this is already in a fraction term. So this is 1 over X plus 1 over 1. Over, let's represent the terms in the denominator as fractions as well. So we have X over 1 plus 1 over X plus 2 over 1. The reason why we want to represent the numerator terms and the denominator terms in terms of fraction is that so that we can be able to solve, so that we can be able to simplify, basically add the terms together. Now, we can achieve this by finding a lowest common denominator or multiplying by the denominator, by multiplying by X over X, so that the denominators in the numerator are the same. So we have X over 1 times X over X plus 1 over X times, so already here we have an X, so we don't have to multiply by, we don't have to multiply by X over X, right? Because we want everything here to have the same denominator, plus 1 over 1 times X over X, over X over 1 times X over X plus 1 over X plus 2 over 1 times X over X. So now this is equals to X squared over X plus 1 over X plus X over X over X squared over X plus 1 over X plus 2X over X. Now we can see that the numerator, all the terms in the numerator have a denominator of what? Of X. So meaning that we can now be able to add those terms. As well as in the denominator, we can see that all the fractions in the denominator, or all the terms that are in terms of fractions in the denominator, have the same domain. Therefore, has the same denominator. Therefore, we will do what? We can then add the numerator. So let's start with this over here, the numerator of the entire expression. So this is equals to X squared. So we take the denominator the way it is, because here the denominator is X. So we put X and then we add X squared plus 1 plus that X over there. Over, now we add all these terms. So we see on top there the denominator is also X. So then that will be, so let's put over there, then that will be X squared plus 1 plus 2X. Now, just to write it clearer, so what we'll do is we write it like this. So this will be X squared plus 1 plus X. So we take this term over there, over X divided by X squared plus 2X plus 1 over x. Now, we actually use what we have learned from the previous video, that we can change this division sign to multiplication. But once we change the division sign to multiplication, this entire term here, sorry about that. Okay. This top term here will become the bottom, and the bottom one will come on top. So basically the numerator becomes the denominator and the denominator becomes the numerator. So now this is equals to x squared plus x plus 1 over x times x over x squared plus 2x plus 1. Now from this term, we can see that this x cancels that x over here. So then this becomes x squared plus x plus 1 over x squared plus 2x plus 1. Now that we have found this expression, therefore, the composition of G and F is equals to x squared plus x plus 1 over x squared plus 2x plus 1. We have found the composite function, so meaning that we have solved this part. But this question wants us to also find the domain of the composite function. Now, to find the domain of the composite function, we first find the domain of the expression of the composite function and the domain of the inner function. In this case, remember, we have that the composite function that we are asked to find looks like this. Meaning that the inner function is what? Is f of x. So we have to find the domain of the inner function. What is f of x? So we go back to our question. F of x is equals to x plus 1 over x. So we have to find the domain of f of x, where f of x is x plus 1 over x. Now, from f of x, we note that the domain of f of x is actually a set of x element of real numbers such that x should not be equals to 0. Because if we choose x to be equals to 0, then the domain of 1 over x will be what? If we choose x to be equals to 0, then if we substitute in f of x, then the function will be undefined because here we have 1 over x. So now let's find the domain of the expression. So the domain, let's write exp just to write expression, right? So the domain of the expression of the composite function, which is this one over here, is x is an element of real number such that x squared plus 2x plus 1 is not equals to 0. So let's factorize that. So this will be what? This will be x plus 1, x plus 1 is not equals to 0. Therefore, it means that x element of real number such that x should not be equals to -1. So meaning that for the expression to be defined, x should not be equals to what? X should not be equals to -1. Otherwise, this expression over here that we have calculated will actually be undefined. So now, to find the domain of the composite function now, meaning that to find the domain of the composition of G and F is equals to the intersection of the inner function. In this case, our inner function is f of x. And so this means the intersection, that sign means the intersection of the composite function as well as the expression, right? The domain of the expression. So therefore, this will be equals to x is an element of real number such that x should not be equals to -1 and x should not be equals to 0. So therefore, we have found the domain of the composite function as well as the composite function. So we found the composite function and the domain of the composite function, and that's how we solve 6.2. Thank you for watching. Sharp, sharp.